Hello everyone, welcome to Mona Patil tutorials. Today we are going to learn Chapter 4 of Science 1, Class 10, Maharashtra board, that effect of electric current. It is one of the important chapter with SSC board in point of view. If you have not subscribed my channel, then please subscribe and press on the bell icon for further notification. Students, I am going to cover the complete chapter in this one video. So, watch for the complete video carefully and watch for at least 2 times for better revision. So, let's start our lesson. So, what topic we will cover in this lesson? First is energy transfer and electric circuit, heating effect of electric current, then magnetic effect of the electric current. So let's we go to our first point, that is energy transfer in electric circuit. Now here you know about the electric circuit is complete with the component like battery, key. Okay, here the resistance given, ammeter given, voltmeter. So suppose all these component come in a line, so they are called circuit. But here for transferring the current, the electron flow is very important, or flow of charges is very important, and that can be possible in the conductor only. So first of all, let me know about the conductor and insulator. So what is meant by conductor? Conductor means having a free electron in it. So the electron can be free and can be move from or flow from one end to another end when it will attach to the cell or battery. But it is very opposite in the insulator. Insulator are bad conductor of electricity because they don't have the free electron. Okay, here you can see the electric circuit. Here R means resistance and two end of this conductor is A and B. Okay, and here you can see the arrow. Arrow means the how the current direction of current is here. Okay, the direction of current denoted here by this arrow. And this circuit has completed by joining the battery here. Plug key for on of the circuit. Okay, V are given for as a voltmeter. Voltmeter used for to measure the potential difference. Okay, and ammeter used for to measure the current in the circuit. So these are the components. Now here the power. So here electric circuit means means obviously we will get the electric power only. So what is meant by electric power? So electric power is equal to energy upon time required. So within a time, how much energy is required? And energy is what? VQ means V are the potential difference or volt, and Q is the total number of charges, and in given time, so upon T. And here you will obtain the VI. How it will be? Now here Q upon T. Here you can see Q upon T means what? I. So I is equal to Q upon T. So that's why instead of Q upon T, we can write here I. So we will obtain electric power is equal to V into I. Okay, why here the AB given? Because AB means the end of the conductor. Okay, from which the flow of electrons will be carried out. Okay, so this is the first equation. Now the sources of energy, like the cell gives in time t the energy P into T to the resistor. If it is the current flowing continuously through the circuit, the heat produced in the resistor in time T will be. So heat will produce in the R. So heat means H is equal to P power into T time. So we will obtain V is into I into T. So because we have already seen here that P is equal to VI. So instead of P we will write VI and into T. So V into I into T. This is the equation number 2. Now according to the Ohm's law that we have studied in the previous chapter, that Ohm's law is what? That V into IR. Okay, potential difference into current into resistance. So V upon IR. So here in the equation number 2, instead of V, we can put this value I into R. So we will get here heat is equal to I square into TR. But here, okay, so here it is the fourth equation. So we will obtain here H is equal to, instead of V, we have put the current square. So that has split it here, I into R into T. So we will get the final equation, H is equal to I square into RT. This is the fifth equation. So, and this is called a Joule's law of heating. Now let me see the unit of electric power. So power is equal to V into I, that is volt into ampere, okay, which is given here as a sixth equation. Now 1 volt is equal to 1 joule upon 1 coulomb, and 1 ampere is equal to 1 coulomb upon 1 second, that is time. Okay, now here 1 coulomb will be cancelled and we will get the unit like 1 joule upon second. It's similar to the watt, or another name of this is the watt. So thus the unit of electrical power is 1 watt. Okay, now next we are going to study about the heating effect of the electric current. When resistor, I show you in the electric circuit where the resistor. So when a resistor is connected in an electric circuit, heat is produced in it due to the current. This is known as the heating effect of the current. Now here you can see here coil. Means one straight wire has coil and again it has coil. So known as a coil. So such a solenoid type of coil are used in the equipments like coil of cooker, coil of heater, where we need the heat. Okay, iron machine is there, ironing machine is there. Here the electric bulb also need the heat. So this heat, how this heat is obtained? In the electric bulb, there is a tungsten wire. This is the tungsten wire. This tungsten wire has the property high melting point. Okay, and it is probably 220 volts. So for the temperature, this or long period of temperature, this is not melt, and that's why it is used for emitting the light. Okay, and this heat effect gives us the light. So this is what heating effect of electric current. The unit of electric power means 1 watt is very small. So unit, and hence the thousands watt or 1 kilowatt is used as a unit to measure the electric power. In practice, if 1 kilowatt power is used for 1 hour, it will be 1 kilowatt into 1 hour of electric energy is used. So 1 kilowatt hours is equal to 1 kilowatt hour is equal to 1000 watt into 3600 second. Okay, so 1 hour means 3600 seconds. So 3.6 into 10 raised to 6 watt second is equal to 3.6 into 10 raised to 6 joule. So this is the unit of electric power. Now next we will see the different type of fuse. Okay, several times what happened, we read also about a building catching fire due to short circuit. Sometimes if we switch on an equipment in our house, the electric fuse wire melts and the electric supply is shut down. Let us discuss about the cases or causes briefly. The home electrical connection consists of live, neutral and earth wire. Okay, in next PPT I can show you this. Okay, these are the 3 types of wire, and you can see these wires are denoted with the different colors. Here earth wire denoted with the green or yellow color. Okay, live wire denoted red and brown color, and neutral wire for blue and black. Okay, so these are the 3 wires used for the household purpose or for carrying the electricity in different places. So the home electrical connection consists of live, neutral and earth wires. The live and neutral wires have potential difference 220 volts. The earth is connected to the ground. Due to the fault in the equipment, or if the plastic coating on the live and neutral wire gives away or worn away, the two wires come in contact with each other and a large current flow through it, producing heat. And suppose in this, if any inflammable material like wood, cloth, plastic, etc. exists around that place, it can catch the fire. Therefore, fuse wire is used as a precautionary measure. We have learned about fuse wire in the previous standard. As soon as high current flow in a circuit, the fuse wire melts and breaks, and the circuit may break the circuit, and any mischief is avoided or any accident is avoided. So many times, particularly in the summer season, huge electrical power is used in the evening due to home lighting, fans, air conditioner, use of electricity in shop, etc. As a result, excessive current is drawn from the transformer supplying the electricity. And if the capacity of the transformer is sufficient, it fuses wire melt and the supply gets shut down. Such an event occurs due to overloading. So these are the different types of fuse you can see here. Okay. These days miniature circuit breaks. So miniature circuit break means MCBs. You may have seen in your houses also. So these switches are used in the homes. When the current in the circuit suddenly increases, these switches opens and current stop. Different type of MCBs are in use for the entire house. However, the usual fuse wire is also used. Then magnetic effect of current. So magnetic effect, you can see here the two circuit, and here near the circuit there is a magnetic needle. You must know the use of magnetic needle to show the direction. Okay, so it is stable at the north-south pole. The magnetic effect is observed because of the current in the wire. This means electricity, magnetism are closely related. On the contrary, if a magnet is moved and kept moving, will we observe any electric effect? So, yes, it is not exciting, it is normal. So, therefore, we are going to study the magnetic field and such electromagnetic effect. Finally, we will study the principle, construction and working of electric motor and electric generator. Okay, so here suppose I will explain about this circuit to you. So, if this circuit has connected, as shown here, connect a copper wire thick and straight as compared to the connecting wires between A and B. Okay, A and B. Keep magnetic needle adjacent to the wire and keep the plug key open in the circuit and observe the direction of the needles. Close the plug key and observe the direction of needle. So you can see here the direction will deflect, or that magnetic needle will deflect. Deflect means it will just change its direction. Okay, and this tells us that is around the magnetic or around the conductor there is a magnetic field, and that has discovered by the scientist here Hans Christian Oersted, and that is why in his honor the unit of intensity of the magnetic field is termed as Oersted. Okay. Next we will see about the magnetic field in practical way. A magnetic field is produced around a straight current carrying conductor. So this red rod is, you can see here, this is the copper conductor. If the current is unchanged, this magnetic field reduces. Okay, as the distance from wire increases. Therefore, the concentric circle representing the magnetic lines of force are shown bigger and rarefied. So as it will be go far away, it will be bigger and bigger. Okay, and they rarefied as the distance from the wire increases. If the current through the wire is increased, the intensity of the magnetic field also increase. Okay. Then we will see about the right hand thumb rule. If you understand it, so further explanation it will be better to understand. So this is the convenient rule for finding out the direction of the magnetic field produced by a current flowing through an electric conductor. Imagine that you have held a conductor in your right hand in such a way that the thumb is pointed the direction of current. Okay, this thumb will point the direction of current. Then turn your finger around the conductor. So these fingers, so direction of this finger is the direction of magnetic lines. Here you can see the magnetic lines. Okay, so this is what a right hand thumb rule. Magnetic field current through a circular loop of the conducting wires. Red color copper wire which has in the form of loop. This is the conductor loop of metal. Okay, and here the circuit has attached to this loop. So circuit, you can see the variable resistance that can be changed for observing the amount of current. Okay, so less current will be there. The effect you can see here in the magnetic lines. So that is why the variable resistance has adjusted here. The ammeter used for measuring current, how much current we are applying there, and battery for the completing circuit. So the electrons or electric circuit will be, or current will be flow. So circuit is completed by connecting various components as shown in figure. If the current passes through the loop, the magnetic lines of force are produced at each point on the loop. You can see here on the both point of loop there is in P or Q. Okay, so their magnetic lines are formed, and as you can see this going up far away from this loop or point of loop, the magnetic lines or circle become bigger and bigger. Okay, so as we go away from the wire, the concentric circle representing the magnetic lines of force will become bigger and bigger as we go towards the center of the loop. Here center of the loop, the circle becomes so big, and that is arc can be shown in a straight line. Okay, so as circle will become so big, the middle line is look like a straight line which has formed here the magnet. You can see here the two poles like north and south poles. Okay, so it is a magnet is formed due to this loop of conductor. Okay, next, magnetic field due to a current in solenoid. So it is also same like what we have seen now in loop, how the magnetic field are produced. Okay, so when a copper wire with resistive coating means like plastic coating or other like rubber coating, okay, is wound in a chain or loop like spring, it is called as solenoid. So here I will show you the exactly what is the solenoid. So this is the spring-like structure. Okay, wounded here, spring-like structure, and this spring-like structure of metal is called as solenoid. So whenever an electric current passes through the solenoid, magnetic line of force are produced in a pattern as shown here. Okay, these are the magnetic lines. How it can be produced over the solenoid. Okay, then you are aware of the magnetic lines of force of bar magnet. The properties of the magnetic field of solenoid are very similar to the magnetic field produced by a bar magnet. One of the open end of the solenoids act as a magnetic north pole and other as the magnetic south pole. So the magnetic line force inside the solenoid are parallel to each other. You can see the line between these are parallel to each other, and one is become a south pole and other end become north pole. Okay. Then force acting on a current carrying conductor in magnetic field. Here the magnet has adjusted, and in between magnet, both the poles of magnet, there between one of the conductor has adjusted, which has given a or which has applied in the circuit. Okay, so in that case you can observe such a loop. Okay, current are flowing and you can observe the loop in this experiment. So this force is exerted on the current carrying conductor. The direction of the force depend on the both direction of the current and direction of the magnetic field. Okay, here schematic diagram means how the loop has formed, that has shown. The magnetic field is perpendicular to the plane of the paper going inside the paper like this. Okay. Now here Fleming left hand rule. In the above experiment, we considered the direction of the electric current and the direction of the magnetic field and found that the direction of the force exerted is perpendicular to both. There is a simple rule relating these three directions. This rule is called Fleming left hand rule. So according to this rule, the left hand thumb, index finger and middle finger are stretched in perpendicular to each other. If the index finger is in direction of the magnetic field and the middle finger points in the direction of the current, then the direction of the thumb is direction of, here you can see thumb, the direction of conductor or force on the conductor. Okay, so this is the direction of conductors. Now on the basis of that, we will going to study about the electric motor. Electric motor. Now here this electric motor, you all are familiar with the motor, and this is actually the boon in our life because many work has done with this motor and many works become easy, like drawing the water from well, okay, from deep inside the earth. So such a motors are used. Okay, now you have various form of energy. You also know that energy can be changed in its form, like mechanical energy, electrical energy, heat energy. Okay, a device changing the electrical energy, just listen carefully, a device changing electrical energy into mechanical energy is known as the electric motor. It's a simple definition here. A device changing electrical energy into mechanical energy is known as electric motor. So around us in our day-to-day life, an electric motor is boon. It is used in a fans, refrigerator, mixer, washing machine, computers, pumps, etc. So here you can see the diagram or actually working of this electric motor. This is the conductor in the loop form. Okay, A, B, C, D. Okay, this is the loop of conductor. Here this is actually metal conductor, and this is adjusted into the magnet between the horseshoe magnet, north and south pole. Here this conductor has adjusted to the axle with the help of split ring and carbon brushes. Here AB is the branch and CD is the branch of this loop. Okay, AB and CD are respectively connected to the here EF brushes with the, and actually it is coated with the insulator, and this has connected to a electric circuit. And here you know the electric circuit contain key and here the battery. And suppose the electricity applied to this, then what will happen? This axle will be start rounding. Okay, here the magnetic field is there, so force can be act on the BA, and this force is the upward force, and that is why, and here on the branch CD, downward force will be exerted, and so due to this opposite force, this loop will start to rotate, and it will start to rotate in the anti-clockwise direction. Okay. So electromagnetic induction, if we keep an electric conductor in magnetic field such that direction of the current flowing through the conductor in perpendicular to the magnetic field. So loop is perpendicular to the magnetic magnetic field, you have seen in the diagram, then a force is exerted on the conductors. Because of this, conductor moves. But if an electric conductor is moving in a magnetic field, or magnetic field around the stationary conductor is changing. Okay. Now next, the galvanometer. So galvanometer is sensitive device which is work on the same principle as that of electric motor that we have studied earlier in the chapter. We can make some electrical measurement with it. A coil is positioned between the poles piece of magnet in such a way that the pointer on the galvanometer dial is connected to it. When a small current, for example 1 millimeter, flows through the coil will rotate and the rotation will be proportional to the current. Okay. Voltmeter and ammeter also work on the same principle. In galvanometer, the pointer deflects on both sides of the zero mark depending on the direction of the current. So this galvanometer show the direction of current. In short, galvanometer shows the direction of current. As we have seen, voltmeter for measuring the potential difference, ammeter for measuring the current, like this. Okay. Now next, Faraday's law of induction. Okay, here the Michael Faradays is not taken a formal education, as he have the habit to read the books and the interest in the electric devices. So he have invented or have contributed the work for us, okay, or for the society. If a current is switched on or off in the solenoid coil, a current is induced in the coil. Such as induction is also observed when the current in the solenoid coil is increase or decrease. Current is induced in the coil or supply in the coil when it is moved aside from front of the solenoid. So from this experiment, it is understood that whenever the number of magnetic line of force passing through the coil changes, current is induced in the coil. This is known as the Faraday's law of induction. The current produced in the coil is called as induced current. Like in previous standard, you may have studied about the induced magnetism. Then Fleming right hand rule. When will the induced current in the electrical conductor or coil be maximum? So it will be maximum when the direction of motion of the electric conductor is perpendicular to the magnetic field. In order to show the direction of the induced current, Fleming right hand rule is very useful. So here you can see in this position the thumb is indicate when right hand fingers like thumb, index finger and middle finger is stretched and they all are perpendicular to each other. The thumb shows motion of conductor. Index finger shows the direction of the magnetic field and the middle finger is the direction of the induced current. Okay. So here this can show with the simple diagram motion of conductor, direction of magnetic field and direction of the induced current. Okay. Now here alternating current and direct current. A non-oscillatory current, oscillatory motion you have studied in 6th standard, types of motion. So non-oscillatory current flowing in one direction in a circuit from the cell to the cell. Such a current is called the direct current or DC. A straight line or against a current changing in magnitude and direction after equal interval of time, which is called alternating current. So here in alternating current, the way or direction of current is changing at the interval of time. Okay. Now here the difference between these two current. Direct current is the oscillatory current. It is not an oscillatory current, and alternating current is the oscillatory current. Here in a non-oscillatory current flowing in one direction and in a circuit from the cell to the cell. Such a current is called the direct current. Here the current changing in magnitude and direction after equal interval of time, which is called as alternating current. The direct current can be stable or can be reduced also. Here it is increases to a maximum, then reduces to 0 and increases to the maximum in the other direction and again reduced to the 0. Then a electric generator. Just we have studied about the electric motor. So in electric motor we have studied that here electric generator. Okay, so mechanical energy is used to rotate the current carrying coil in a magnetic field around an axle and thereby producing electricity. So here electric generator is working on the principle that electric mechanical energy convert into electrical energy, and electric motor that electrical energy convert into mechanical energy. Okay, and this is actually difference in both. So here working, this is the horseshoe magnet, north pole, south pole, and between this pole the coil or loop of coil is adjusted, which having two branch BA and CD. You can see that arrow represent the direction of current. Okay, and here B1 and B2, these are the brushes used, and R1 and R2 are the carbon rings, and this has adjusted to the axle. Okay, this is the axle, and here the circuit has completed from B1 to B2, and here between a galvanometer are used to measure the direction of the current, as just we have studied here. Okay, and when actually working of this is what, according to the Fleming right hand rule, electric current is produced in the branches AB and CD in the direction A, B and C to D. Here A to B and C to D. Thus what will happen? The flow of current in the direction A, B, C, D will be seen. So external circuit has given there the current flow from B2 to B1 through the galvanometer if instead of one loop coil, a coil consisting several turn is used and the current of magnitude several time flow. After half rotation, the brushes AB takes the place of branch CD and the branch CD takes the position of branch AB. Therefore, induced current goes as DC to BA. But the branch BA is always contact with the brush B1 and branch DC in the contact with the B2. Hence, external circuit current flows from B1 to B2. Okay. Here B1 to B2. It will be flow like this. Here they have shown the direction also. Okay. So here the axle rotate with the help of machine from outside, and because of this a coil ABCD start rotating. The stationary carbon brushes B1 and here the B2, okay, are connected to a galvanometer which show the direction of current, and upon rotating the axle, this axle will rotate, the branches AB goes up and CD goes down, and in this way this loop will be rotated clockwise. Okay, and there you have studied in the electric generator it was moving anti-clockwise. Okay, and here we have finished this lesson. So thank you for watching this video. I will make a separate video on electric motor and generator, as they are the most important topics and also big topic. The videos will become very large. If you had liked my video, then press on the like button and share this video to your friends. We will meet in the next video. Till then, bye bye.